Hello students, welcome to Physics for All YouTube channel. In this class, I am going to explain about interference of light. Interference of light is defined as follows. When two or more light waves superimpose in the medium, then according to the principle of superposition, the two waves added with each other. It gives resultant wave whose amplitude is equal to the sum or difference of individual wave amplitudes. Because of variation of the amplitude causes intensity also. The variation of intensity in the region of superposition is called as interference. This interference phenomena can produce fringes or bands. Basically, this interference is classified into two types. Number one is constructive interference and number two is destructive interference. Constructive interference definition: when the resultant wave amplitude is equal to the sum of amplitude of individual waves, then such interference is known as constructive interference. Destructive interference: when the resultant wave amplitude is equal to the difference of the amplitude of individual waves, then the interference is known as destructive interference. To know about interference types, let us consider the two diagrams. In this slide, there are two waves are represented. It is a wave 1 which has amplitude A1 and another wave which has amplitude A2. The crest of one wave will superimpose on the crest of another wave. Because of superposition of one wave on the another wave, it will produce a resultant wave. Now, this is the resultant wave. If you can observe the intensity of resultant wave is more than the amplitude of the individual waves, it causes variation of intensity. This interference is known as constructive interference. Now, coming to the destructive interference, again as usual consider this is wave 1 and it is a wave 2. Here this position is called as a crest of one wave and this position is called as a trough of another wave. So, when crest of one wave superimpose on the trough of another wave, it will produce destructive interference. If we observe resultant wave amplitude is equal to the difference of amplitude of the first wave and second wave, therefore, this phenomenon is known as destructive interference. This is another diagram to know about constructive interference and destructive interference. Here is the crest of one wave will superimpose on the crest of another wave, which will give resultant wave whose amplitude is equal or more than to the amplitude of the individual waves. It is the example for the destructive interference. Crest of one wave will meet with the trough of another wave. It will give resultant wave whose amplitude is equal to the difference of amplitude of first wave and second wave. Because of this process, it will give destructive interference. This is another diagrammatic representation of interference. Here, all the red color indicates one wavefront, black color indicates another wavefront. This is one wave and it is another wave. Here black color represents maximum of one wave, which is nothing but crest antamu. This is a red color indicates minimum of the wave, which is called as a trough. This is one wave, it is another wave. If you can observe this diagram carefully, here red color which is known as minimum of the wave, this minimum of the wave will superimpose on the minimum of the wave will superimpose on the maximum of the wave. Now, this position is called as destructive interference. Now, if you can observe this dot going to, this is called as maximum of one wave and this one is known as maximum of another wave. When maximum means here crest of one wave will meet the crest of another wave, it will give the constructive interference. This is another example for the constructive interference as well as destructive interference. This is another example for the interference. Here this is slit 1 and it is slit 2. From this slit 1, one type of waves are coming. From the other slit, another waves are coming. These waves and these waves are going to superimpose with each other. Because of superposition of one wave with respect to another wave, it will give interference. Because of this interference phenomena, it will produce fringes. Here the fringes are two types, circular fringes and parallel fringes. In this slide, I am going to show about circular fringes, which has dark fringes and bright fringes. Dark fringes is because of destructive interference and bright fringes is because of constructive interference. In order to get interference of light, now we have to follow some conditions. Now we will discuss what are those conditions one by one. The first foremost important condition is the light source we have to use should be coherent in nature. Here what is the meaning of coherence? Coherence means the emitted light photons has same phase and all the photons are in the same frequency. Such source is called as coherent source. Second condition is the light source should have monochromatic nature, that is it has to give monochromatic light, that is it has to give single color, that means single wavelength it has to give, that is the meaning of monochromatic. Coming to the third condition, the distance between the two light sources should be closer to each other, then only superposition is possible, then only we will get the interference phenomena. And another condition is the distance between the two light sources and the screen should be large. To see interference fringes, the background of the screen should be dark. Then another condition is the amplitude of the two light waves should be nearly equal or equal. The two light sources we have to use in this emission of interference, we have to use narrow light sources we have to use. This question is important for 2 marks question in terms of JNTU Anantapur affiliated colleges. Coming to the coherence, coherence is defined as the light sources are said to be coherent if they have the same frequency or wavelength and the emitted photons are the same phase. Such source is called as coherence. Coherence is divided into two types. Number one is known as spatial coherence and number two temporal coherence. Coming to the temporal coherence, the light source is said to be temporal coherence when there exists a phase relation at a point on a wave with respect to the another point on the same wave, then it is known as temporal coherence. Whereas coming to the spatial coherence, it is possible to predict the phase relation at a point on a wave with respect to the another point on the second wave, then it is known as spatial coherence. Thank you students for watching.